Do you know indices is related to standard form and logarithm, or even sort? What is indices? Indices simply means exponents. Indices means exponents, exponents, power, yes, or power. So indices simply means exponents or power. So how do we solve math questions involving indices? And do not forget that in other subjects, um, standard form, we do have indices there too. So we use the knowledge of indices in standard form. We use the knowledge of indices even in sort and also in logarithm. So the laws of indices are the same, yeah, with the laws of logarithm. So now let's look at the laws of indices. What are the laws of indices? What are the laws of indices? So the first one is what you can call the multiplication law. So let's call it the multiplication law. So the multiplication law simply says that when you multiply, you add the exponent. For example, we have a raised to power 1 multiplied by a raised to power 2. So that simply becomes a raised to power 1 plus 2. So that is the multiplication law. And also we have the division law. So what is the division law of indices? The division law of indices says that when you divide, you take away the exponent. So using a as our base as well. So let's have a raised to power 3 divided by a raised to power 2. So that simply means a raised to power 3 minus 2. So which is going to give us a raised to power 1. So in this case, we have a raised to power 3. So that is for the addition. So for that, we also have the zero power law. So that is the zero power law. Let's look at the zero power law. The zero power law says that anything raised to power 0 is equal to 1. So this simply means that a raised to power 0 is equal to 1. So meaning that any figure that has the exponent of 1, exponent of 0 is equal to 1, is equal to 1. As you can see, we use this also in conversion of bases, like other bases to base 10. So where we have any figure is by 0, then we have it to be equal to 1. So as you can see, they are related, very related. So aside that, we also have the powers of power law. So the powers of power law. So what I like to call the power of power law, let's have it like this. So I like to call it the power of power. So the power of power law. So what does the power of power law says? It says that if we have a raised to power, let's say n into bracket of a raised to power uh, m, a raised to power m. So what this means is that you multiply the exponent. That means you have the first exponent inside the bracket on the base and the other exponent outside the bracket outside the base. So that means you multiply them. That becomes a raised to power n multiplied by m. Let's put it that way. So that is the power of power law. So we also have the negative power law. The negative power law. Let's continue the law here. So we have the negative power law. Negative power law. So what negative power law says is that anything raised to negative will become a fraction. For example, a raised to power negative 1 will be equal to 1 over a. And okay, let's make our exponent to be bigger than 1. So that would be a, let's have a raised to power negative 3. That would be 1 on a raised to power 3. So that is a negative power law. That will be 1 divided by a raised to power 3. So that is a negative power law. So aside the negative power law, we also have the fractional law. Fractional law. So the fractional law is in two types. Let's look at the fractional law. Okay, so after the fractional law, which means that anything raised to power that has the exponent of a fraction, you multiply, like let's say we have a raised to power 2 over 3, a raised to power 2 over 3. So that is going to be, the denominator here will be the root, that will be the cube root of a raised to power 2. So meaning that you have to find the cube root of the figure first, of the base first, then you uh, now find the exponents, that is the number of the exponents it has. So I think these are the basic rules in indices. Please, in case you've not subscribed to this channel, please help to subscribe and put on the notification button to know when new videos are uploaded. So the laws of indices are just these little ones that we've had, and we can also have the in a fractional law we may also have a fraction in a power like this. Let's have this, like we have a over b into brackets of, let's say, n. So that simply means a raised to power n divided by b raised to power n. So that's also under the fractional law. Under the fractional law. So, but one thing I would like you to note in this law is that when you have a fraction as the exponent, just know that the denominator is your root. So that we bring the radical sign on the base, while the numerator is the exponent. So now let's have a basic revision on all these laws of indices, and you try to learn them while we solve some questions in our next video, or you watch the all-in-one video that has everything. Please subscribe to this channel. So the first law is the division law, which means is the multiplication law, which means that when you are multiplying in indices, you add the exponent. You add the exponent. The second is the division law, which means that when you divide in indices, you take away the exponent. So that's what that means. The zero power law, that means that anything raised to power 0 is equal to 1. So that's a basic. And the power of power means that when you have this like this, a power inside of a bracket and a power outside of a bracket, you just multiply the two powers. So that's the power of power. And the negative power law, as we have it here, means that when you have anything raised to negative, so that means the negative sign will make the base a denominator, while the exponent will just be there like this. So, and the negative will just make the base to be a denominator. So that's exactly what we have here when we have a raised to power negative 3, and that you see that the exponent here will be the new base, while the negative sign means that it is a denominator. So meaning it says send it to division. While the next one is the fractional law. So in a fractional law, what it simply means is that anything raised to power that has the power of a fraction, it means that you divide with the denominator of the fraction and you multiply with the numerator of the fraction. And in case you have a fraction like this as well, what it simply means is that these two, since they are joined together by a bracket, they both share these exponents. They both share that exponent. In another way, you may also have a two figure in a bracket that is a power of products. Let's look at the power of products before we call it a day. So the power of products. So the power of products. So let's look at the power of products. So what power of product simply means is that in case you have something like AB into exponent of let's say n, let's use n, that is the unknown. So what this simply means is that a raised to power n multiplied by b raised to power n. So you should know that in case you have something like let's say we have 2x raised to power 2x raised to power let's say we have 2x2 raised to power 4. So what is this simply means is that our 2 raised to power of 4. So which will be multiplied by our x raised to power of these two. We have to use the product, the power of power law here. So that is going to be 8. It will be 8. So that means in this case, you're going to have 16x raised to power 8 as the final result. So this is the power of product rule. That means when you have products and they have the same power, and that's just. So it's not about actually the names. It's not about the names that they are called. It's understanding that matters. So thank you for watching. Please subscribe and put on the notification bell. As you can see, indices is actually easy, very easy. And when you're doing these indices, you just need to remember the law. You apply the law whenever you have a question, whether it is a kind of algebraic indices or a plain indices, as we have some of them on the board. And do not forget that indices also is related to to algebra. In fact, algebra is the key in most math topics. Very key. So now we're going to solve these 3 questions, and I think they are quite selected for indices. And please, if you need more questions, you search online for questions, or you chat the number displayed on your screen for more questions in case you want it. I will actually send some questions I can practice with on indices, and you send the answer to me for correction. So now let's solve these questions, and you can see that what we have here is just a plain division law of indices. So what we do first is that we divide these two. So that is going to be 12 divided by 4 in brackets, and we have that in bracket. So then we have our exponents one after the other. So that's a raised to power 5 minus 2. So don't not forget its division. Numerator comes first, into b raised to power 4 minus 1. So why do we do it that way? So numerator comes first when you are dividing. Do not forget that is the division law of indices. So this is going to give us 3. So that becomes 3, and our exponent here, that will be a raised to power 3, a raised to power 3. Yes, that's 5 take away 2, and b raised to power 3. And at this stage, this becomes our final answer. Very easy to do, very easy to solve indices. And if you check this very well, that is like the product of products. And also we have this 4, so the exponent here is working for both 4 and a. So meaning that we need to put this our a exponent 4 and in brackets to be matched with another bracket, which is going to be our a exponent 3 and 4. So if you use the product of products rule, then you see that these two can be multiplied. When you have something like that, you multiply them. So this will be 4 exponent 4. I believe that should give us 216 or something. So now let's do the math. So 4 times 4, 16 times 4, 64. 64 times 4, that's 16, that's 24, 256, I think. Yes, 256. So that gives us 256, and a exponent, you multiply these two, a exponent 12. So that is our final answer for this. So for the next one, you will see that there is a negative power there, and also we have the fractional power. So a negative power and a fractional power. So that automatically becomes 1 over 27. Okay, so this becomes the root. Okay, the root, cube root, and this 2 becomes the exponent. This 2 becomes the exponent. So this is what we have. So that will be 1 on the cube root of 27 square. So you find the cube root first. So that becomes 1 over that cube root, that should be 3. That's 3 square. And 3 square is going to be 9. That becomes 1 over 9. Final result. Final result for that. So indices is very easy. Try to solve more questions, and we're going to look at the one that we're going to eliminate the base. So that means we make the base to be equal and eliminate the base in order to solve it. So in our next video. So thank you for watching. Please subscribe. So we're looking at unknown power here. So in case you want to solve this, you actually need lots of indices as well. And of course, you need your number, understanding of your number, your square root, cube root, to be able to solve this as well. So in case you've not subscribed to my channel, please subscribe and like the video. So now let's continue with this. So in this case, we are looking for the x. We are finding the x in all of them. So, and the x is unknown. So this is number 1, 2, and 3. So the x is unknown. So to find the unknown, we have to give them the same power. We express this according to the power of the exponent. So we make sure that the base, which is 2, are equal these two. So we express this as the power of 2. So if you want to express that, that should be 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32. So that's 2 exponent 5, right? So that is going to be 2 exponent x is equal to 2 exponent 5. 2 exponent 5. So in this case, we eliminate the exponent, 2 cancel 2. Then our x will be equal to 5. So this is how to solve when you have your exponent to be unknown. So the same thing we did here, we're going to do the same thing here. So where we have, so we make this to be power of 5, we make this base to be power of 5. So you can see, since our base here is 5, so that means we have 5 exponent x is equal to 5 exponent 3. So that should be 5 times 5 times 5. So 5 times 5 times 5 gives that, right? So then at this stage you eliminate the 5s, then your x is equal to 3. Final result. So the last one, to do that, you express this to be exponent of 4. That should be 4 times 4, 16. 16 times 4, 64. So that should be 3 raised to power 3. So we have 4 exponent x plus 1 is equal to 4 exponent 3. And in the same manner, we eliminate the 4s. 4 cancel 4. So that means we now have our x plus 1 is equal to 3. And do not forget, we are looking for the x. We are not looking for x plus 1 is equal to 3. So that means this 1 is going to travel to this side. We collect the like terms. So that becomes x is equal to 3 minus 1. And our x will be equal to 2. Our x will be equal to 2. So thank you for watching. Please subscribe and do not forget to practice more videos to solidify your understanding on indices.